Okay, we're going to look at another application of integrals, and this is to find arc lengths, okay? So if we have a shape, okay, that looks something like this, okay? Now, one of the ways that we can, can kind of estimate this is I could find kind of a couple of different points on here, and I could straight connect them, okay? Kind of go up here, and then maybe I go up to here, and then maybe I come down here, and then I go over to here, and then I finally end up down here. And I could find the length, okay, using a distance formula, okay? I could find the length of each of these segments. Now, the concept, though, okay, is I need to get these points closer and closer and closer together so that we minimize kind of the amount of difference between the green arc and the orange line segment, okay? So the concept here is, okay, that the way we do integration, okay, is that we find, okay, okay, formula-wise, okay, so if f prime is continuous on A to B, okay, then lengths, sometimes called arc lengths, of f of x from A at A f of A to B, okay, so we're going from one point to another, okay, is the integral from A to B of the square root of 1 plus f prime of x squared dx, okay, which is also sometimes noted as the integral from A to B of 1 plus dy dx squared dx, okay? So we're going to take a look, okay? Now, what's a little bit different about this one is we do need to find f prime. We are going to need to find the derivative of this function, okay? So here is the concept. So we're going to look at an example, okay? So we are going to look at the function y equals 4 square roots of 2 over 3 x to the 3 halves minus 1. And we want to run this from 0 to 1, okay? I know it looks just lovely, right? Okay, gorgeous. Okay, so first thing, getting some stuff. A is 0, B is 1, okay? So now I'm going to find y prime. Okay, so here we go. 4 square roots of 2 over 3 times the 3 halves is going to come down. That's going to drop by 1, so it's going to come down to x of 1 half, and the 1's going to go away. So, doing some cleanup here. The 3's will go away. This and this will go down to a 2, okay? So I have 2 square roots of 2 x to the 1 half, okay? So now, when we put this into the formula, we actually needed to have it squared, okay? So I'm going to do 2 square roots of 2 x to the 1 half, and we're going to square that. So this is going to be 4 times 2. So the 4 is here, the 2 is coming from this, and then x, because that's going to be square root of x squared, okay? So this is 8x, okay? So now, playing with this into our pretty little formula, I'm going to try and move this over just a little bit. Okay, we're going to do the integral from 0 to 1 of the square root of 1 plus 8x dx. Okay, now, need to do a little bit of kind of u substitutions here. Okay, I'm going to do this up here. So u equals 1 plus 8x du dx, okay, is going to be 8. So that is going to be 1 8 du equals dx. Okay, sorry, I got a little line over there. So dx. Okay, so we've got, and I'm going to be sloppy in my notation here, u 1/8 du. Okay, because I'm going to send this back anyways. Okay, so I've got 1/8 integral of u to the 1/2 du. So I've got 1/8. That u is going to go up to the 3/2. So I've got 2/3 out here in the front. Du. I'm going to clean that up a little bit. It's going to go to 1/4. So I'm going to come back out. So it's going to be 1/12, 1 plus 8x to the 3/2 evaluated from 0 to 1. Okay, now normally I would be like, oh, let's just, plug some stuff in, whatever else. Okay, no. Okay, if I plug in 0, not in this case. Okay, so I'm going to get 1 plus 8. So I'm plugging in the 1, so it's going to be 8 to the 3/2. So that is 27/12 minus 1 plus 0 to the 3/2. Okay, minus 1/12. Okay, that is going to be 26/12, which will go down to 13/6. Okay, so there is our length. Okay, and we could certainly push that down into a decimal if we needed to. Okay, and guys, where this stems from, okay, hopefully you kind of recognize when we saw that square root and the stuff in there, we saw the square thing. This is all stemming from like a Pythagorean theorem idea, okay, is where this is really stemming from, that they want us to go through and find. Okay, so let's take a look at another one. Okay. Oops, sorry. Move this up here. Sorry, I'm playing with a new stand here. Okay, so we are going to look at f of x is x cubed over 12 plus 1 over x. And we're going to go from 1 to 4. Okay, so first thing I'm going to find is f prime of x. Okay, now, guys, that is, just because my brain does not like to process this, that is 1/12 x cubed. Okay, so when that 3 comes down, that's going to be 3 over 12, which is 1/4 x squared. And guys, that is x to the negative 1. Okay, think about exponents there on that one. So that is going to be minus x to the negative 2. And again, I need to have that lovely little bugger squared. Okay, so we're going to do 1/4 x squared minus x to the negative 2 squared. Okay, It's going to be 1/16 x to the 4th minus x to the -4. And don't go combining stuff, okay? Remember all of your rules that you were supposed to remember, okay? For all of this loveliness, do not, okay? Okay. Now, this one, I'm sorry, y'all. I messed that up. I did what I always tell y'all in class not to do. I did full square the first, square the second, and didn't do a bunch of stuff in between. Okay, let me try this again. So 1/16 x to the 4th. I'm going to get 1/4 times this twice. So -2 times 1/4. Now, guys, here the powers will cancel off, so that'll go to there. And then plus x to the -4. Okay, awesome. I messed that one up. My bad. Sorry. That's -1/2 plus x to the -4th. Okay. Now, this one, they're actually showing, well, let me not do that. Okay. Integral from 1 to 4, square root of 1 plus 1/16 x to the 4th minus 1/2 plus x to the -4th dx. Okay. Do a little bit of playing here. I've got 1/16 x to the 4th. Let's see, plus 1/2 plus x to the -4th dx. One fourth x squared plus x to the -2 squared. Yeah, I think so. Yeah. Squared and square root will go away. So this one's got a little bit of an algebra trick in it. So we've got integral from 1 to 4 of 1/4 x squared plus x to the -2 dx. Integrating that back up. That's going to go to x cubed. Which means I need a 1/3, so it's going to give me a 12th x cubed out here in the front. Let's see. That's going to go back up to a -1, so it needs to be a minus. Evaluated from 1 to 4. So plugging in the 4th, so 4 cubed, 64. So I've got 64 divided by 12. We'll do math inner. So we've got 16/3 minus 1/4 minus a big set of parentheses. Sorry, move down here. Plugging in the 1, it's going to be 1/12 minus 1. So I've got 16/3 minus 1/4 minus 1/12 plus 1 is the negative. And we get 6. Okay, nice, pretty clean, pretty number. Okay, with that one. Okay. Now then, if they ask you to do something Sorry, my little whiteboard keeps moving around here. Okay. They can ask you to do some stuff. You can do the same rule setup, okay? You can go from C to D, square root of 1 plus G prime of Y squared dy, okay? If things are done in terms of y's, okay? So if they ask you to do something like this, where they do this in terms of y's instead of x's, it can make life a whole lot easier, okay? So for example, okay, we're gonna look at y equals x over 2 to the 2/3, and we want to go from when x is 0 to x is 2. Okay, now first off, if I plug in 0, y is 0. Okay, and if I plug in 2, I get that y is 1. Okay, now you may be thinking, well, why? It's a perfectly good function. It is. It's kind of a pain in the butt right now. Okay, so solving this for x so that I have it in terms of y, if I do the reciprocal power over to the other side, I now have 2y to the 3/2 equals x, okay? This is slightly cleaner looking than we had before, but this is now our integration stuff, okay? So I'm going to call this g of y is going to be 2y to the 3/2. G prime, sorry, move down, y is now going to be, okay, so the 3/2, I got 2 times 3/2, y to the 1/2, those are going to cancel. So I've got 3y to the 1/2. So now g prime of y squared, we're going to square this, so that's going to be 9y, okay? Looking a whole lot prettier, because guys, up here, if I would have done this derivative, okay, I would have had something like 1/3 x to the negative 1/3 power, and then we've got to square that. It's a little uglier. This is a little bit nicer, okay? So we'll bring this over. So we're going to integrate from 0 to 1, okay? Square root of 1 plus 9y dy, okay? Now, guys, this looks really familiar. Guys, we just did one where it was like 1 plus 8x, okay? And if you remember, I had a 1/8 that had to get pulled out into the front of this, okay? So I'm going to have an integral from 0 to 1 of 1 plus to the 1/2 dy. I'm going to need a 1/9 to come up out of the front end of that. This whole thing is going to go to the 3/2, so I need a 2/3 up here in the front, and we're evaluating from 0 to 1. So we've got 2 over 27, 1 plus 9y to the 3/2, evaluated from 0 to 1. Okay, for that. And again, I'm going to let a calculator help me out here. So 1 plus 9. That's not going to get pretty. Okay, let's see. 2 over 27 times 10 to the 3/2. If I plug in 0, that's going to be 1. That's all going to keep it at 1. So minus 2 over 27. Let's see. This is going to be, oops, sorry. Move down here a little bit. This is going to be, I'm going to factor a 2 over 27 out. That is going to be 10 square roots of 10 minus 1 for that part. Okay. Guys, basically, I've got, if we think about this in terms of 10, 10, 10, I can bring a pair of these out and it leaves me the other one left behind. Okay, so that's where I came out with this. There is an exact answer. Sorry, there is an exact answer. Again, you could push that over to decimal if you needed to. Okay, that would be dependent upon if it asks for it to be an exact answer or not. Okay, so that is arc lengths. So hopefully that's fairly understandable. Again, it's just another application that we're allowed to do with our integration stuff.